Welcome to Vitamans. Today we want to continue with universal function. We want to look at one interesting function also, and that is LCM using the reducing method. And before we go to that, we are going to see how we used to do LCM based on our elementary mathematics, respective of any level which we are used to. It's very interesting. Stay tuned. And we're going to use MS Paint as an application to do elementary mathematics, finding the LCM of any given numbers. It's very interesting. It is from there, after that elementary mathematics, using the method which we are using, then we are going to computerize it using Python programming here for you. Now, to start, remember, we have to have a question like this. Find the LCM for instance 4, 8 and 10 numbers. Take them like that as they are. You are taught to find the LCM for this number. It can be as many number as you want. See, let me just make a callback what we are using. Now we used to say, we put the number, for example, 4, 8, then 10. Okay. Then we used to draw a table like this. We should draw a table like this. Remember? We should draw a table like this. Our elementary mathematics, our mathematics. What we used to do, we should do like this. We should draw a table like this. We draw. You don't worry the accuracy. I'm after you understanding. Remember? I'm using Paint. Try to use Paint because every application window has, every operating system has this. I want to use the easiest application that everybody can get on any operating system of Microsoft without finding problem. That's why I've tried to use Paint. Okay, don't worry with my speed. I'm interested to you who want to observe what I'll be doing. Remember also, we need to say now, if you have these numbers, okay, if we look at them, and then we should say we are going to begin with the lowest common factors, and we are going to use the method that is division methods. There are many other methods, there are around 3. Let's begin with that one, the one which we are using it to at our level. If we call back now, you could say the lowest factor is 2. You put it 2 here. Now what we used to do, you say this number here, you divide it by 2, and then you could get 2 here. You say 2. Okay, the lowest factor beginning with 2, depending on the number. It is not a must. And remember, I used to say that it cannot be as many as whatever. This is why I've told you we want to computerize it using Python programming. You will see if it come. Let's begin with this. Now, then 8 divided by 2, you could get 4. You go on like that. 10 divided by 2, get 5. Then the balance, which could put 0. Remember, you go on like that. The next lowest common factors here, it is still 2, because we have 2 here, we have 4, we have 5. Okay, now you should also put 2 here again. I say 2, something like that. Then you say, continue. Now 2, because this is the lowest common factor, you have to divide it. 2 divided by 2, here you say it is 1, like that. You go on. 4 divided by 2, you get 2. Then because 5, it is not divisible, you can divide it but get the remainder. We are interested in remainder has to be 0. If you see this one, it is bringing a remainder which is not 0. Don't take it. You take it, leave it as it is, you take 5. You go on like that. put 0 there. Now we go on here. Now the next lowest common factor C2 is still common here. You see, put a 2 here. Don't worry, I'm taking you step by step. You learn and you become a master. Now go on now. Now C2 here. 1, if you say 1 divided by 2, impossible. Okay, it can be divisible, but our concern LCM, we have to get the remainder who is 0. If it is not remainder 0, don't never to put in decimal places here. So it has to remain there 1. You can say 1. That's what we used to do at our level. Now 2 divided by 2 is 1. You go on like that. If you see that when you get this number here, you divide it by this lowest factor, you get decimal places, never, you leave it as it is. Your interested remainder has to be here 0. That's a protocol. Okay, now here 5, you go on like this is 0. Next, what next as the factors has to be 5. Has to be 5. Do you know why? There's no any other number remaining divisible by 2. If it is finished, you got the next number, that is 5. Now you go here, here you say it is 1. The main has this 1. Now 5 divided by 5 is 1, and the balance here is 0. In the end, we used to say when you reach at the end like this, that's the ending. What we have to do next, we have to get the answer. The answer, the simple answer would be here. It is 2 times 5, which is equal to, when you multiply 2 times 2 is 4, 4 times 2, 8, 8 times 5, 14. Has our answer. You remember? So this is the end. So you could get your marks, all of it. The method they use, they could give you, and the marks. For example, if it was the marks, this one was taking 3, then you get your 5. As we used to do, that's the mathematics which we are using. These are functions. We are using those methods. Here we are now computerizing the thing to come up with the easiest way of doing that by using the software, and the software are designed by programmers. Therefore, we want you to learn these things from the elementary mathematics. You computerize that, you stress, you become a software engineer in the long run. That's the strategy. Now, let's see computerize our elementary methods. As we said, this is the methods which were used before, me and you, at that stage, if you remember very well. Now, we are going to use Python programming. Python programming has many libraries inside them, and for this case we want to use the Python library. It also has universal function Python. Okay, universal function, as I said before, they are mathematical function. There are many. Python has a library specifically which can handle that, and this library is called NumPy. We begin by importing it here in Jupyter Notebook, like doing this: import NumPy as NP. You run. When you run, it will take you to the next cell. Here, the next cell, you simply enter, for example, the variable. You can say, you can define an object. Say, for example, x is equal to NumPy, NP, it means NumPy. Then you say array, like that, array function, parenthesis, square bracket. You put in your element for CM, as we said, there are these ones here, which are 4, 8, 10. You can put them inside here, straightforward. You say this is 4, 8, and 10. When you run, it will take you to the next cell, meaning that no error is accepted. Now the next, you have to call in the function specifically in NumPy. Their function also, there are many, because specifically deal with handling scientific computing, data science, machine language, anywhere on the planet. It is applicable. Even in research, it can be used. Okay, now, how do we do that? We can define an object, or it can remain the same object as X. Whatever, Python has no problem. Now, what we do, let me define an object which is different from the above. I say it is np dot. Now I bring in the LCM. This name LCM, lowest common multiple. I will say lowest common factors. So now we say here dot reduce. Reduce method, it is inside NumPy as a method. Then you call in your X here, our entity, because this is X which is assigned to this. Then you say X, you run. When you run, it will take us to the next step. Now you would wish to print your output for this. How do you do that? You can say maybe C, or you can say print. If I say print function, then I put C inside my parentheses, I will get an output. Now the output here is for same as we go here using this method which we are using the tool to all of us. This is the importance of it. Learning Python at the earlier stage, you want to learn it will help you, enable you to understand very well how can we design other application at the earlier stage. In that time in the future, you'll be able to be amongst those who will become software engineering, developing an application that can be used in society day-to-day life. This is where we are.